We plugged in -4, we decided that that doesn't work, right? And then we plugged in 0, 1, 4, 9, 16, and 25. Any reason why you think I picked those numbers? Braden?
So they all can be square root.
Yeah, they're all perfect squares, and I wanted easy stuff to look at, right? So the square root of 0 is what? 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And the square root of 16 is 4. And the square root of 25 is 5. So my points at 0, 0, 1, 1, 4, 2, 9, 3. Okay, now this is a little bit different than when we do squared or when we do the absolute value, because we're not going in both directions. We're just only going in one direction for this. Okay. Notice our pattern is going out 1, up 1, and then out 4, up 2, and out 9, up 3.
So is it like the opposite of?
Exactly. It is the opposite of squared, which should make sense since squaring and square rooting are inverse operations. So out 1, up 1, out 4, up 2, out 9, up 3. On this particular graph, we have a minimum value, and that minimum value is 0. Our end point, we do not have a vertex because we don't have two sides, right? So there's not two sides coming together. So we don't have a vertex. Instead, we have an end point at 0, 0. And our domain is actually changed because remember, our domain represents what are the possible x values. And we decided we can't plug in any negative x values, right? Because we can't take the square root of a negative. So our domain for this will go from 0 to positive infinity. 0 is included, and we're going to positive infinity. Our range will start at the y value of 0 and go up to infinity also. So what's different here? Well, there's no vertex. There's no axis of symmetry. We can't cut it in half. And it only goes in one direction. And I'm actually going to put in parentheses, it only goes right. So I'm going to put right there. And then the domain is not all real numbers. Okay? The other two, there's no limit to what x can be. I can plug in any x value I want. But when we're talking about square roots, there is a limitation. For our domain, we could have also said that x is greater than or equal to 0, or y, and the range could be y is greater than or equal to 0. Those are two different options. And depending, if it asks for interval notation, you do it the first way. Otherwise, you can do it the second way as an inequality. All right. Sliding up. How are they similar? There's a pattern. And I'm going to say it's opposite of x squared, right? And there is no slope, right? So there's no constant rate of change. There is an average rate of change, but no constant. So that's the same as absolute value and quadratic, right? Both of those don't have slopes. They have average rates of change. So one of the other things to look at is this, like x squared turned on its side and lost its reflection. So we're talking about like half a parabola that fell over. Okay, we are going to look at the triads. We're going to we're actually just going to go to example 2 here. It doesn't match my old notes. I forgot we changed it. Okay, anybody have any idea what the negative a value is going to do to the graph? Yes.
It's gonna make it go down.
It's going to make it go down. So we would still start, if we wanted to graph both of these on here, the first one, the Q, I'm going to graph that in blue, Q of X. That would start here and it would go over 1 up 1, over 4 up 2, over 9 up 3, right? That's the Q of X. But the P of X, that one's negative. So it would go over 1, down 1, over 4, down 2, over 9, down 3. So don't confuse yourself that that is one graph. Those are 2 separate graphs. The blue is different than the green. There is an x-intercept at 0, 0, and a y-intercept at 0, 0 for both of them. The domain of the second one is still from 0 to infinity, but the range is going from negative infinity up to 0. Remember, we talk about bottom to top or left to right when we talk about our domain and range. Domain and range is left to right, and range is bottom to top. Okay? What do you think is going to happen on part B? Any guesses? Yes.
We're gonna multiply the like up 1, out 1, up 4, out 2, like that. By,
change the up values
yes,
by 4. Okay, so it's probably going to change the steepness of our graph, right? So we're going to start at 0, 0. We didn't change that. We're going to go out 1, up 4. And then we're going to go out 4, and then instead of going up 2, we're going to go up 16. Oh my goodness. 4, 10, 11, 12, 13, 14, 15, 16. That's going to be way the heck up there. Okay, so that changes the steepness. My x and y intercepts.
It's disconnected.
That is disconnected. Yeah, it won't reconnect. It keeps telling me it won't pair. That's why I made you guys sign into Zoom so that you can. That's okay. It is true. It is not connected, but I can't get it to connect.
Just for sure.
Yes.
Wouldn't since you multiply the up values, right?
Uh-huh.
So we would multiply up 2 times 4. So wouldn't that be 8?
Yeah, you're right. I did just do this wrong because I'm trying to do too many things at once. So we're supposed to be going out 2, up 4, and we're multiplying. No, that's. So we would go out 1, up 1, no matter what, right? So we're going out 1, up 4. And then we would go out 4 up 2. That's 8. Yes. Out 4 up 8. That makes more sense. Thank you. I appreciate it when you call me on my stuff. So it's better. If we just go ahead and write it down and then we multiply times 4, and then I won't make those mistakes. So out 9 up 12 if I want to go out there. That's only a little bit off the graph. Okay. Thanks for calling me on that. Appreciate it. Okay, so my x and y intercepts are still at 0, 0. Your y-intercept's at 0, 0. Your domain is still from 0 to infinity, and your range is still from 0 to infinity. Okay, go ahead and do the try-its. You want me to leave that and not scroll yet? All right. So domain and range didn't change, but the steepness, right? More steep, less steep. So this is called the vertical stretch. This is called a vertical compression. If I wanted to talk about what's happening horizontally, the first one would be a horizontal compression, and the second one would be a horizontal stretch. So it would switch with the vertical. Okay, I'm going to slide up here. Okay, how is this going to affect it? What do you think the plus 3 is going to do on the outside?
Gonna make it, or you're gonna have to multiply the out values. Oh wait, on the outside?
Yep, this plus 3 right here on the outside. It's just going to shift us up 3. We're still going to go up 1. We're going to go out 4, up 2. Sorry. Out 9, up 3.
Where did that shift us? Wait, do you mean, like we shift on the x-axis or the y-axis?
It's up 3 on the, so we're shifting up 3 because it's on the outside. Just like on our absolute value graphs or our square root graphs, if we have a k value, which that plus 3 is a k value, it's shifting our starting point up.
It's not shifting it over?
No, that's inside, shifts us left and right.
Okay, and the outside shifts it.
Yep, the rules will stay the same for that. So then this one here is going to shift us left 3 because it's on the inside. So remember, inside we do opposite. So we're going to shift left 3. Okay, and still go out 1, up 1, and go out 4, up 2, out 9, up 3. Okay, so this is shifted left 3, it's a horizontal shift. Now, the domain then changes on this one to be from -3 to infinity, and the range is still from 0 to infinity. With brackets. On this one, the domain is still from 0 to infinity, but the range changed, and the range is now from 3 to infinity. So the outside affects our range, the inside affects our domain. Go ahead and do the triads. Okay, who could tell me what the domain and range are of your first triad there? When we shift down 4, what's our domain?
-4 to.
Okay, so domain is x values. How far to the left did we go? 0. And then we went to the right forever. Bracket, not parentheses. And then our range goes from, what's our lowest point? -4 to positive infinity. Okay, what happened to the domain on the right? How far left can we go?
6.
How far right can I go?
Infinity.
How far down can I go?
0,
How far up can I go?
infinity.
Okay, does that help with domain and range? Okay, domain, how far left can I go? How far right can I go? Range, how low to how high? Okay, hopefully that'll help with that. All right, we're gonna put it into, what does H and K tell us here? Opposite H and regular K is not going to give us a vertex, it's going to give endpoint, right? Give us the endpoint because there is no vertex. So remember it's opposite H and K. So when we look at this again, we have our A value. What does our A value do?
It determines steepness.
Right, steepness. Another word thing to call that is so vertical stretch or compression. If your A value is greater than 1, it gets steeper. If your A value is between 0 and 1, so a fraction there, it's less steep. Sorry, I can't fit it all in my box. We'll do H, and we still have a horizontal shift, right? And we know that the square root of x minus h will move us right, and x plus h will move us left. Our k value is a vertical shift. And this is plus k moves us up, minus k moves us down. Go ahead and do the triangles. Okay, this time they're wanting you to give the max or min. First of all, why is it sliding around? Okay, does this first one have a max or more of a minimum? Does it have a maximum value or a minimum value? Any ideas? This one is a maximum because it tops out. You can't go above right there. And what is that value? 1. Has a max value of 1. This one has a minimum value of -4.